hopes the ozone layer is recovering have been dashed by new research showing it continues to decline in the most populated areas of the world. Ozone levels have shown signs of recovery around the poles since efforts in the 1980s to curb the use of damaging chemicals. But scientists have now discovered the ozone layer, a substance which absorbs UV radiation from the sun, is failing to recover at lower latitudes where the majority of people live. This could place billions of people at risk of being exposed to increasingly powerful cancer-causing UV rays, especially towards the equator, where sunlight is stronger. Researchers aren't sure why the ozone layer is declining, but they suggest climate change and short-lived substances, VSLSs, from industrial chemicals could be to blame. Scroll down for video. Study co-author Professor Joanna Hay, co-director of the Grantham Institute for Climate Change and the Environment in Imperial College London, said, ozone has been seriously declining globally since the 1980s. But while the banning of CFCs is leading to a recovery at the poles, the same does not appear to be true for the lower latitudes. The potential for harm in lower latitudes may actually be worse than at the poles, she said. The ozone forms at tropical latitudes of the stratosphere, which is the region of the atmosphere between 6 and 31 miles, 10 kilometers and 50 kilometers, altitude, before spreading around the globe. The decreases in ozone are less than we saw at the poles before the Montreal Protocol was enacted, but UV radiation is more intense in these regions and more people live there, said Dr. Hay. The Montreal Protocol was agreed in 1987 to phase out damaging CFC chemicals, used in everything from aerosols to refrigerators. Studies have shown clear signs of recovery around the Antarctic, where an ozone hole had formed, and elsewhere. But the new study, published in Atmospheric Chemistry and Physics, found it is likely not recovering at latitudes between 60 degrees north and 60 degrees south. London is at 51 degrees north. The cause is not certain, but the researchers believe it is possible climate change is altering the pattern of atmospheric circulation, causing more ozone to be carried away from the tropics. They say another possibility is that very short-lived substances, VSLSs, which contain chlorine and bromine, could be destroying ozone in the lower stratosphere. VSLSs include chemicals used as solvents, paint strippers, and as degreasing agents. One is even used in the production of an ozone-friendly replacement for CFCs. Dr. William Ball, who led the analysis, said, "The finding of declining low-latitude ozone is surprising, since our current best atmospheric circulation models do not predict this effect." Very short-lived substances could be the missing factor in these models. To conduct the analysis, the team developed new algorithms to combine the efforts of multiple international teams who have worked to connect data from different satellite missions since 1985. They use the data to create a robust, long-time series. Dr. Ball added, "The study is an example of the concerted international effort to monitor and understand what is happening with the ozone layer. Many people and organizations prepared the underlying data, without which the analysis would not have been possible. A hole in the ozone layer that appeared above Antarctica in the 1980s has shrunk thanks to a worldwide ban on chemicals, NASA has confirmed. Ozone depletion varies with the weather, making changes over time difficult to study. Purple and blue shows areas with the least ozone. Although individual datasets had previously hinted at a decline, the application of advanced merging techniques and time series analysis revealed a longer-term trend of ozone decrease in the stratosphere at lower altitudes and latitudes. Researchers say the focus now should be on getting more precise data on the ozone decline. They also say it is important to determine what the cause most likely is, for example by looking for the presence of VSLSs in the stratosphere. Dr. Justin Alsing, who worked on the statistical technique of the study, said, "This research was only possible because of a great deal of cross-disciplinary collaboration." My field is normally cosmology, but the technique we developed can be used in any science looking at complex datasets.